Okay, so we just looked at right triangles, and that would have meant 89 is sort of the largest number, 89.9, blah blah blah, but definitely no negative angles. But if you look at an angle as a rotation, then you can have positive angles and negative angles, and we can end up with numbers, basically any number that you want. So here's the picture of an angle that has the starting position of the ray is called the initial side. So a ray would be just a line that has an end on one side, right, and it continues. So here's the initial side. And then if we rotate this way, if we rotate counterclockwise, we call that a positive angle. If we rotate this way, counterclockwise, we call that a negative rotation. And then we could rotate positively and go beyond one rotation, and so this is how you can get angles larger than 360, for example. And so you have all of this out there. So one of the things that we have to think about, or have to try to remember, is how do you remember that counterclockwise is positive and this one is negative? So this is the best way that I can think of it. Doesn't mean it's perfect, but if I put this on a coordinate system like this real quick, okay, then rotating this way would be what? Up or down? So up must be positive, and rotating this way must be negative, because that is down. So now based on rotations we can definitely get positives and negatives. You can see that based on rotations we can get numbers larger than 90 and find sines and cosines, hopefully. So you can get basically any number you want if you think of it as a rotation. Are we okay with that? Alright. If you place an angle on a coordinate system like I just did a moment ago, then we say that the angle is in standard position if the vertex of the angle is at the origin. The vertex of the angle is at the origin. So that just means that we center it here, right? Yes? And the initial side is along the positive x-axis. So this is what we call our this is the starting position. Are you okay with that? That's supposed to say starting. So that's our starting position. And then in this case, we rotate it in a up direction, so this is a positive rotation. And then here's the picture. What would it look like if I had a negative rotation? You would start still on the x-axis, but if you want negative, you rotate this way because you're going to go down, so this would be a negative angle. Are you guys okay with all that? So then one of the things you have to sort of get comfortable with is the different pictures and what stuff looks like. So you have a couple problems in your homework even that look like this. So I'll draw some pictures and I'll try to talk about it a little bit, but so what do we have? Well, it might help to mark some things in here. So this is 0, right? So starting would be 0 degrees. A right angle would be how much? 90. So that's 90, right? That's a right angle. This is a straight line. That's 180, right? Then this must be 180 plus 90 again is, that's 270 degrees. And then we add 90 plus 270 and we're back at 0, but that could also be considered how many degrees? 360, because one way all the way around is 360 degrees, right? Are we okay with all these? Okay. So if I'm asking you for a picture of a 25-degree angle, you know that 90 is here, so you're in quadrant 1. So I'll take something like that. That's good enough for me. Okay, and that's all you have to draw. You don't even have to show me in which way you rotate it. So how does 140 degrees look? Well, you're going to be in second quadrant, right? So this is 90. That's 180. So you're a little bit closer to 180 than 90. So I'll take, you know, things that look like this. That looks good, right? I'll give you one that I probably wouldn't accept, and then maybe you guys can tell me why. So why would I not accept this one for 140? Huh?
Probably not even 100.
Right. Well, it's probably 100 because it's definitely past 90, but you know, it's not past the halfway point. It's got to be a little bit closer to 180 than 90. So, you know, make sure that you're like halfway or just a little bit past it on this one. Okay, so that one was not good. So other than that, you don't have to be too precise, because there's, you know, unless I want to give you something that you can really measure it with, like a protractor, then there's no way to do that. So how do you show 270 degrees? Just put an arrow right here. There you go. 270 degrees. Now on this one, you know, maybe this would have helped a little bit, right? But if you just label this as 270, then that would be fine as well. Are we okay with these? Oh yeah, and that's, I generally, especially in the beginning, I think it will help if you would label these with the measurement that it's supposed to have. So how about negative angles then? Well, I'll do a little bit here. So this is still 0, right? And this is a right angle in the negative direction, so this would be a negative 90, negative 180, negative 270, and then you better be all the way around again in one full rotation, even if it's negative, so you're back at negative 360. So negative 45, well, that's halfway between 0 and 90, right? So that looks like this maybe, and say that's a negative 45. Okay, and then negative 290, so, yeah, 290, so 90, 180, that's a negative 270, so we got to be a little bit further than that, not much, just, you know, 20 degrees. So there's a negative 290 degrees. So you should be able to draw pictures for these angles and get your terminal side, so terminal is where you end, right, to terminate, your terminal side in the right spot. Okay with the pictures? Alright, so now let's connect it to sines and cosines and all that mess. Now, I will define it for all of these here, but then find the exact value of the trigonometric functions. When you see this question, you just have to do sine, cosine, and tangent for right now, because after that it would just be flipping stuff, right? So let's first show you what theta is. So theta would be this rotation for our example here. Okay, so we're going to call that is theta. And if you put things on a coordinate plane, then we can associate x's and y's with it, right? So this point has an x and a y. Yeah? If I mark straight down from the x and the y, then I can make a triangle. Okay with what I'm trying to show you here, if I can find my marker. So if I make a right angle here, so notice that we do connect it back to right triangles. If I make a right angle there, then this is the y value, right? And the x value is the base of the triangle. We're good? Okay, so what was the sine of an angle in terms of Sohcahtoa? The sine would be what? So the sine should have been, in a normal right triangle, the sine would be, well, you do the same thing here. The sine of theta would be opposite. Well, so what you end up doing is you look at it from this angle. Okay, so we're going to stand over here and say that we're going to look from here. So opposite is our y, right? So the y value is usually connected to the sine, and then the hypotenuse, so I'm going to put a little m here, and I'll tell you in a moment why that's an m. Okay, and I can tell you this already, it stands for magnitude. So the sine would be y over m. So the same kind of thinking, the cosine is going to be what? Use your normal definition for cosine. Cosine is adjacent, which is x, over m. And then your tangent would be y over x. And your cosecant is just this thing flipped, isn't it? Cosecant would be the sine flip. So, and this is why I say you don't have to find these in the problems, because if you can find the sine, you can find the cosecant, and vice versa. Alright, and so these you can just flip it. So you notice that so this is still flipped. So to me, the definitions of sine, cosine, and tangent, they still work. We just got to look at, if the rotation is theta, so in this case it's past 90, then the angle that I'm actually looking for, so that I can look at it from a right angle perspective, ends up being different than the original number. And I can do that over here. So we'll basically, this is basically the picture that goes with 120. What I mean with this is, if I were to draw 120 degrees on a coordinate grid, it would look a lot like the picture that I just explained, right? Yeah? Does this make sense so far? Does that picture look like 120 degrees? Okay, so I'm going to go straight down. Okay, so if this is 120 degrees from here to there, then can you tell me what angle I have left over here? What's that angle there? If that's 120, how much do I have over in here? 60. And if that's a 60-degree angle, don't I know the sine and cosine and tangent for these? Because I can put like the special triangle lengths here, right? So this would be 1, square root of 3, and this side would be? What's the hypotenuse worth here? 2. And so the sine of 120 degrees ends up being what? Opposite, which is square root of 3 over 2. The cosine would be? Okay, now you can write that already, but that's not completely true. If this is an x up here, and that's a y value, then this 1 is not really a 1. That's supposed to be a? Look at your x. You go from here, from 0 to the left. So your x is probably going to be? You're on a coordinate grid, guys. This isn't 1. This is supposed to be? Isn't that supposed to be -1? Aren't we on a coordinate grid? And then this is why when I just did, and I did this for the sine, but some angles give you negatives. Because sometimes you get a negative x, and sometimes we'll get a negative y. Are we okay with that being a -1/2? And then the tangent would be what? Square root of 3 over a -1, which would be a negative square root of 3. Okay? Alright. Let's do one more. And then I'm going to go back and talk about magnitude here in just a little bit. So 225 would be where? It's past 180, right? Yeah? This is 180. How much past 180 am I for 225? 45. So if that's 225, then this angle here must be 45, right? So there we go. We have another special triangle. 45, 45, 90. The side lengths here are what? Well, so they are 1, 1, and square root of 2. However, is your x positive or negative? Negative. Is your y positive or negative? Negative. So put negatives in your little picture, otherwise you're going to forget these. So that when you find your sine and your cosine, etc. So the sine of 225 degrees is going to be what? You're in this angle here. Sine would be -1 over the square root of 2. The cosine of 225 degrees is? Same thing, okay? Including the negative. And it doesn't always have to be the case, so they could be different for multiples of 45. And then the tangent of 225 is? Right, because a -1 divided by -1 is actually a +1. Okay. Alright, let me talk a little bit about magnitude and things like that. So, you guys have noticed now that we can get positives and negatives, right? Yeah? Okay, the reason I call this magnitude is because this value here, and the magnitude is m, right? How can you find m? Well, I know that m squared must be what? X squared plus y squared? I don't know why I wrote it backwards. So m is what? M is the square root of x squared plus y squared, right? Well, when you square x and when you square y, what do you know about the sum of that? That's definitely a number that's squared is always positive, right? So you add two positives and then you take the square root, so you definitely know that m is always M is always positive. Okay, so that's why I said magnitude, because magnitude just implies a positive value. Okay, well, how does that matter? Well, it matters the following way. Whether or not the sine is positive or negative does not depend then on the hypotenuse, does it? Because the hypotenuse is always your magnitude. That's always positive. So why was this sine positive? It's because the square root of 3 was? The square root of 3 is? Positive or negative? Positive. So if the y value is positive, so if you have to go up, then your sine will be positive. If your x is negative, then your cosine is negative, because the magnitude is always positive. And then the tangent here is negative because one of them is positive and one of them is negative. And again, so it has nothing to do with the magnitude. It comes from the fact that when you find a tangent, you're dividing the opposite side by the adjacent side. So if you have one positive and one negative, you get a negative, right? But look here, why is the tangent positive? One negative and one negative makes the tangent positive, because a negative and a negative make it a positive. Okay? And I'll give you a little hint or suggestion for that in just a second. So we'll check back and we'll come back to this again. So last thing here is 330. So where's 330 degrees? Well, that's close to 360, right? How much am I short of 360? 30. So this angle is 30 degrees. Are you guys okay with that? Alright, so the reference angle, guess what that is? The reference angle is the angle that we end up using. So, and it's always made with which axis? The x or the y? Yeah, you always make it with the x. So the reference angle is the angle to the x-axis, always. Okay, that we draw to make a 90-degree angle, right? Do you guys see that? So we want to make a right, I guess a right triangle is what we're looking for. So we always draw it to the x-axis, but we draw it to the shorter x-axis. So, you know, I could have drawn it something from 330 all the way back to the other x-axis, but you just make a picture so that you have a right triangle with your x-axis. Okay, that's a special triangle. Square root of 3. Is the y up or down? So that's a -1. And this will be 2. And so you see that you can find angles of rotations based on special triangles. Now I have to give you, like, this would not have worked for 320 degrees, right? Because we don't know 40 degree, so, but it only works for special ones. But for these special triangles, we can still find sines and cosines without using a calculator. So the sine here would be a -1/2. The cosine of 330 degrees apparently is the square root of 3/2. Notice that the cosine is positive again, right? And the tangent here, is the tangent positive or negative? It's a negative, right? Because one of them is positive, the other one's negative. So it's a -1 over the square root of 3. You guys okay with all this? Alright, so I think the next slide I'm going to go through sort of quick then. But this, oh no, I do have them both on the same. So this little table here summarizes when things are positive and negative. Now, that table to me is a little confusing, so I'm going to see if I can help you with that a little bit. And to do that, we're going to use this little silly sentence that says, all students take calculus, which is not necessarily true, but it helps. So the A here really does stand for all, and what it means that all trig functions in quadrant 1 are positive, because x is positive and y is positive, right? In quadrant 1. The S here stands for which of the trig functions do you think? The S is a sine. So in quadrant 2, your sine will be positive. Why is it? Well, because the y value is still positive, right? Well, what does that mean then for cosine and tangent? The cosine and the tangent are going to be negative. Okay, so I just remember where stuff is positive, then I know everything else is negative based on that. So all students take, the T stands for tangent, so that means that the tangent in quadrant 3 is positive. So then sine and cosine must be negative. And the C in calculus stands for cosine, so that means the cosine is positive here. So that means that the sine and the tangent must be negative. So this is how you can sort of memorize, or at least figure it out quickly, is your sine or cosine supposed to be positive or negative? Now I usually draw pictures for all my reference triangles and all of that anyway, and so when I'm on a coordinate plane, notice that in my coordinate planes I actually labeled the x's and y's negative when they were supposed to be negative, right? So I do that so that I don't really have to think about it. I just make sure that I do it right in my picture, and it will come out right in the ratio. Okay, this is part of your homework, so I don't think you have this anyway, so this is the worksheet that I was talking about.